Welcome to my video on the cross or vector product. This is lesson 6 in my series on vectors. Before we get into that, what I want to do is do a little review. First of all, I want to go back and look at the dot product. It's a form of vector multiplication. It's kind of a semantics there as far as what that is exactly, but we started with A dot B. That was our dot product from the last video. That's equal to the magnitude of A times the magnitude of vector B times the cosine of the angle theta. And this turned out to be a scalar quantity. It didn't have a direction, just a value. And that's for the vectors A is equal to A1, A2, and A3. That's the X, Y, and Z components. The B vector is B1, B2, B3. Or you can also see in this notation A1, A2, A3. Now the cross product is also you can think of as a form of multiplication. It's probably more closely associated with it because it does have a direction. So A cross B, this is not multiplication sign here, it's a cross product or the vector product. The C vector is perpendicular to both A and B. So C is equal to A cross B, which is equal to A, the magnitude of A, times the magnitude of B, times the sine of the angle between the two vectors. And this is times this normal vector, which is just the unit vector. So this is going to be perpendicular. That's the one I was talking about. That's perpendicular to both A and B. Now I'm going to make a graph of these vectors. So let's start out with A. There's our A vector. There's our B vector. And then there's the resultant vector, C. Okay, so, and then the angle between them is theta, whatever that angle is. And then, so this is the normal vector, that little unit vector that I showed you just a second ago, in the direction of C, of unit 1. And so these would be like not necessarily in the I or J, so we can't really say that you got unit vectors associated with them. Now, one property also of this is if we extend this out here, the A vector and the B vector parallel, just like we did in vector addition, this area turns out to be the magnitude of A, B, product of that, times sine of theta. So that's the area of that parallelogram formed by A and B vector. So that's how we think of this graphically. Now, to determine the direction of the C, we use what's called the right-hand rule. And you'll see this in other areas. But what it does, you put your first vector, you put your hand in the direction of A vector, then you move it towards the direction of the B vector, and then when your thumb goes in the direction of C. So you can use you have to use your right hand. And it's one way of telling which direction the C vector is going to go. It's called the right-hand rule. So next I'm going to look at some properties of the cross or vector product. The first one is it's not, not commutative. And that is A cross B is equal to minus B cross A. And if you think of it in terms of the right-hand rule, if you're going one direction and then you reverse that direction, you're going to get a different direction for the vector. So it's not commutative. Now, if A and B are parallel, A cross B is equal to the null vector, or the same thing as A cross A is equal to the null vector, or 0. And that makes sense because the sine of the angle between two vectors that are parallel is 0. So in this case, if they're parallel, the sine of theta goes to 0. Now the distributive law does hold. And so what this is, if we've got x a cross b plus c vectors. That is equal to a cross b plus a cross c. So it is distributive. Now if we look at the unit vectors, how they behave in terms of the cross product, since I is parallel to I, the cross of that is 0. J is parallel to J. We saw that parallel vectors cross into 0. And K is K cross K is equal to 0. And here's our unit vectors. So that's going to be our X, Y, and Z direction. X is the I unit vector. J is the Y, and K is in the direction of Z. Now, just using our right-hand rule, if we take the case where I cross J, that's equal to K, and let's verify that. So if we start here in this direction, pointing this direction, the X direction, rotate it in the Y direction with our right hand, the K is going to be, our thumb would point in that direction, which is the K direction. So this makes sense in terms of the right-hand rule. And now we take J cross K, that's equal to I, and J cross I, K cross I is equal to J. So that's what happens to our unit vectors when we start working with those. Well, I hope you'll learn a little bit about the cross product, the vector product. I'm going to go into this in further detail in future videos. And I'll thank you for watching.